Hello, beautiful people, and welcome. In this video, we are talking about logarithms. Now, this is going to be an introductory video. We're talking about what logarithms are, how to convert from an exponent to a logarithm, and from a logarithm to an exponent, and evaluating logarithms using the change of base formula. As always, I am human. If I make a mistake, that's okay. I would like to learn from them, so let me know where the mistake occurs. All right, let's go ahead and talk about this in the green thinking bubble. So this says log base b of a is equal to x. I'm actually going to write that down. So that's log base b of a is x, or is equal to x. Now, logarithms are exponents. I'm going to repeat that. A logarithm is an exponent. So I'm going to write that. A log, we're going to abbreviate logarithm by just saying log, is an exponent. And the reason I want to say is an exponent is because when we translate is an exponent, if you were in Algebra 1, Integrated Math 1, we were translating from math to English and English to math. Is always translates to equal sign, and then you have an exponent. So when you're writing, here's is, and here's your exponent. So what is a logarithm? A logarithm is an exponent. It's another way to write an exponent. Again, is equals. That means your exponent is after the x. So let's go ahead and, so a log of base b of a is x. So let's do that one more time. So I'm going to take this equation here. So log base b of a is equal to x. So how does that work? If we are given a log, how do we rewrite that into an exponent? Well, think of it as a counterclockwise. B is your base, is an exponent, x is your exponent, and then your a is your result, right? Is your result. So think of it this way. You're going counterclockwise. Let me actually get another color. You're going counterclockwise. Your base, your exponent equals a. And that's how you're going to convert from a logarithm to an exponent. So let's do this. Log base b of a is equal to x. We are going to go counterclockwise. So b, x is your exponent, is equal to a. So that means you have b to the x power is a. Now let's say we want to do it the other way. If we start out with b to the x is equal to a, we're going to convert that by writing it as a logarithm. So counterclockwise as well. B is your base of a is x. B of a is x. So your base is b, your a is your of a part, and then your x is x, or you can think of it as an exponent. So how do we rewrite this? Well, if you have an exponent and you need to rewrite this in terms of a logarithm, you're always going to start with log, L-O-G, and then you're going to write base b, which is smaller and lower. It's like a subscript of b, of a is equal to x. Let's do some examples. So we're going to do an example of writing a logarithm as an exponent, and we're going to do an example of an exponent being written as a exponential form being written in a logarithmic form. Okay, so example number 1. Let's say we have log base 3 of 9 is equal to 2. And I want to write that in exponential form. So I'm going to do counterclockwise. What is a logarithm? A logarithm is an exponent. That means 2 is my exponent. That means 3 is my base. And that means it's equal to 9. So how do we rewrite this? We're going to rewrite this as my base is 3, my exponent is 2, and that's equal to 9. Let's do another one, example 2. Now let's do one that says log base 4 of 1/16 is equal to -2. And you guys can't see that. I'm going to move this up. So let's rewrite this in terms of an exponent, exponential function. Okay, base is 4. What is a logarithm? A logarithm is an exponent. So that means my base is 4, my exponent is -2, and that's equal to 1/16. Now let's go the opposite direction. So now let's use exponential form to get to my logarithmic form. So number 4 I think I skipped number 3. So let's do number 3. So let's do this one. Log base 9 of 27 is equal to 3/2. Now, I said we were starting with exponential form, but I decided to do one more example because I've written log and I'm writing in pen. So again, your base is 9, your exponent is 3/2, and that's equal to 27. Make sure that you are aware that you're going counterclockwise when you are rewriting. Now let's do example 4. And we have 14 squared is equal to 196. Again, we want to rewrite this in terms of a logarithm. So we're doing the counterclockwise. My base for my exponent is 14. So I'm doing log base 14 of 196. And that's equal to my exponent, which is 2. Do one more example, example 5. Let's do 36 to the 1/2 power is equal to 6. How do I rewrite that in terms of a logarithm or logarithmic form? And that is my base is 36, so log base 36 of 6 is equal to my exponent, which is 1/2. So don't let logarithms scare you. A logarithm is just an exponent. It's another way to write an exponent. Remember, a logarithm is an exponent. All right, let's go ahead and jump in to evaluating these logarithms. So let's say we have log base 7 of 49. And they're asking us, let's do this is example 6, and they're asking us to evaluate this. Well, here's the thing, you guys. If you're trying to get to a calculator, don't do it, because a calculator will only give you something in base 10. If your base is not 10, or what is called a common base, then it will give you the wrong answer. So don't do it. Just evaluate it by hand. Rewrite this in terms of a exponential form. So we're going to do this. We're going to say log base 7 of 49 is equal to something. We don't know what that is. We want to evaluate it. Well, what is that? Let's do counterclockwise. So that means 7 to what power is equal to 49? Well, 7 to what power is what? 7 squared is 49. So that means that your x value is 2. Or you can say that means that log base 7 of 49 is equal to 2. Let's try another one. Let's try, this is going to be example 7. Let's do this one. Log base 12 of 1 is equal to something. I'm going to write x here. Counterclockwise to rewrite it. That means I have base is 12, exponent is x, is equal to 1. 12 to the what power is equal to 1, and that means x is equal to 0. And let's do one more, example 8. Hopefully you're starting to see the pattern. A log base 3 of 243 is equal to, again, we're going to write x because we're trying to evaluate this. So that means I have counterclockwise. The base is 3, my exponent is x, and that's equal to 243. Now this one, I don't know what this one is, so I'm going to use my calculator, and I'm just going to guess and check. So I have 3 to the 3rd power, too small. 3 to the 5th power. Oh, that is it. So then I'm going to say x is equal to 5. All right, now let's talk about change of base. So let's say you have something that's not perfect. Okay, so let's say you have example, what number are we on? Example 9. So let's say we have something like log base 16 of 64. And we're saying, again, we want to evaluate this, so we're putting an x. Counterclockwise, so I have 16 to what power is equal to 64? And I have no idea what that is. I can spend my time guessing and checking. But let's say I want to use a calculator. So what we're doing when we're using a calculator, we have what's called the change of base formula. And I'm even going to put it in a box here. It's super important, especially if you're trying to use a calculator. It's called the change of base formula. And that means when you have log base b of a, whenever you have a log, right, base b of a, you can evaluate that, or you can change the base to a base 10 by saying log base 10 of a divided by log base 10 of b. Now, a lot of times you will not see this 10 because 10 is a common base. Because it is so common, we actually don't write 10. So that's why on the calculator, whenever you see log, you will not see this 10. It is implied. So let's evaluate this one here using the change of base formula. I have log base 16 of 64 is equal to, and if you're not sure which one goes on top, which one goes in the bottom, think alphabet. A is first, then goes B. So log of A, which is 64, divided by log of B, which is 16. On my calculator, this is exactly what I'm going to do. I'm going to find my log button. It is not ln. ln, we're going to talk about that a little bit later. So here's log. Notice I don't have a base on my log. That is because it is common. It is always 10. Log base 10 of 64 divided by log base 10 of 16. I'm going to press enter, and that gives me 1.5. So that means my log base 16 of 64 is equal to 1.5. And you can use a calculator. All right, let's do one more example, example 10. And let's do this one. And we can do, what do we want to do? What do we want to do? Let's do this one. Log base 6 of 1 over 36. To use the change of base formula, we're going to say log of A, which is 1 over 36, divided by log of B, which is 6. Typing that into my calculator now. Log of, and I'm going to put this in parentheses because it's division, 1 over 36, divided by log of 6, and that gives me a -2. And that is pretty much it for the introductory lesson for your logarithms. For your assignment, if you're in my class, you will have lots of practice on this. Make sure that you know how to use change of base. Make sure you know how to evaluate them without a calculator. You're going to have to show proof of that. And as always, thank you so much for watching my video, and I will see you in my next one. Bye!